In this video, I will show you how to set up a simulator for an embedded board. I'll use the STM32 as an example, but it supports other platforms. We'll use the Zephyr RTOS, but it works in other environments too. I'll also show you how to set up a debug session that works much like a real hardware. So first you must have VS Code installed, and then we should go to the marketplace and install Workbench for Zephyr. So the purpose is to have a working Zephyr environment. So the Workbench for Zephyr, you search for it, you select this extension, and then you have to install it. Click on install, you trust the publisher, and here it will take a few seconds in order to install the extension. So once installed, you're going to have the extension here added to your VS Code, and it will also show up some pop-up notification to install the host tools. So you click on install host tools. So this is needed in order to install Zephyr host tool dependencies, which are some tools needed in order to have Zephyr working. This step might take 5 to 10 minutes depending on your internet speed. And in case there any issue here, I will leave in the description a link to known issues to give you some workaround in order to make it work. And I also there's also another video if you'd like to go more in depth about the Workbench for Zephyr and to debug it on a real physical board, and see also other features as well. So once it's done, it will tell you that everything was installed successfully. You must first import the toolchain. We're going to import Zephyr SDK. We're going to use the minimal because we only need the ARM. So here you specify the version. You select ARM architecture because STM32 only supports ARM. Here we just select the folder, and we just click on import. So it will now download the Zephyr SDK and set it up. So then you must initialize the workspace. Here we have many templates. We'll start from a minimal template, where this minimal template is only for the STM32. We select the version, and then it is better to just create a subfolder for the where we're going to place the Zephyr workspace. Let's call it Zephyr project here. And you must select this folder. So you just click on select, and of course you must import it. So in this step, West is going to import the Zephyr code and also the different modules. So the different modules, these are external modules that are needed by Zephyr in order to have it working, like the STM32 HAL and also the other HALs that are needed, and the other code also needed for debugging and doing other features. So here you accept this new project to be added. And you can see it added to your setup. Now you want to create a new application. You select the workspace you just imported and also the toolchain. And for this board, we're going to use the STM32 F7 discovery board. So you just select this board, specifically this board. And now we're going to here you can search for any sample to get started with. So let's start with a simple project, the Hello World project. You select the location where you want it to be created. There you go, and then you click on create. So now it will just create a new project for you, a new application, the Hello World application. Now to build it, there are many ways. You can do right-click build or click on the build icon. There are also many other features. I will let you discover them or check the other video. There are many other features in here. So now we go to the Hello World project. You click on source and you open the source code. This is really very basic Hello World, just a simple printf. To build it, you just click on the folder, right-click and build. So now it will just build the Hello World application. So here, if you feel the build is a bit slow on Windows, this is a known Zephyr issue. This is because of the Windows Defender. It makes the build very slow on Windows. I also left in the known issue how to exclude the folder and make the build significantly faster. So now you have the build ready. You can see the build was successful. So in order to debug it, we go to the marketplace again, and we need to install Zazu Simulator. So because we want the simulator of the STM32 board and also other boards. So you click on Zazu Simulator. You must install now this extension. So once installed, you can see the extension here, and you must authorize also this application. You can see it here installed to your VS Code. So the first step is to install the dependencies, which is basically going to install the different templates, so different board templates. You do click on install dependencies. Here is just going to import the different, download the different templates and other program needed. So the configuration here, in order to create the setup, here we have many templates, many boards. So from the NXP, IMX, RT to the Nucleo, but we're going to use the STM32F7 this code, the basic one. And here we select the Hello World project. Once selected, it will automatically detect many things. It works seamlessly with Zephyr Workbench, but it also works with other extensions. So we can run or debug it. So let's debug it first. So when you click on debug, the first time it will ask Renode to be to authorize the access. So the first time, just make sure you authorize the access to Renode when it appears. So there you go. You just click on authorize, and then the simulation will start. And there you go. You have your simulation working. And here you have the printf, and if you can just do step overs or continue. You can do whatever you want. So if you do step over here, you can see the hello world printed to the serial. So you can see here that you have the different, you have also different peripherals like LEDs, buttons, and so on. So let us do the blinky LED. By the way, in case of any issue here, I recommend to close VS Code and start again. It's sometimes if you do not accept them, it might get some issues. So let's start by creating a new application now. Again, we're going to create an application for the Blinky. Also make sure to stop the previous debug session. So like same as before, we're going to use the discovery board. And we select now the Blinky project. You search for Blinky. Make sure you use the basic Blinky project. You select the location here, any place. You select and you create it. So now you have the Blinky project. So by default, almost all boards in Zephyr, they have an LED configured to be used. So let's build the application and run it. Now we go to the Zazu Simulator, the configuration. It has already the same thing. So here we just select the Blinky project. We keep the same template and we debug again. So now when you click on continue, you can see the LED start blinking. So this is the onboard LED that is already configured by Zephyr. So if you want to use the other LEDs, here you can see at which pin they are configured. So in order to use them, you must create an overlay and change the LED to be blinked. So let's take an example. I will go to the Blinky here, to the boards, and I will create a new overlay file. So the name of the file must be the same name of the board. So the name of it is going to be STM32F746G_disco.overlay. And I already prepared here an overlay that's going to configure the orange LED. So here I have the orange LED, it's GPIOI pin number 3. And I will change the alias LED0 to this orange LED. So LED0, why LED0? Because here in the sample, we're going to use the alias LED0. So you also must be called build pristine, rebuild the pristine, because we needed to detect the new added overlay. Oh, here we got an error because by mistake here I didn't use the node label. So it is, or you should have used the orange LED as node label. So just fix this and rebuild again. So now the build was successful. You go back to the Zazu configuration and you debug it again. So now we have changed the LED from the onboard LED to the external orange LED. So let's continue. And there you go. You must have the orange LED start blinking. Okay, so I also want to show you that we have also many other templates. So the same board with additional peripherals, like this one has the BME 280 and a potentiometer. The BME 280 is a nice square C temperature sensor, and the potentiometer is connected to the ADC. So there you go, you have the board with the different peripherals. You can click on the potentiometer on the BME. Here you can change the temperature. You can also change the potentiometer value. I hope you enjoyed this video, and if you wish to see other boards supported, just leave us a comment. Thank you.